Okay, let's look at this question over here. So this one, right, what we have here is that we have sine A positive, right? So how you tell is you look at sine and positive. Look at tangent and positive like that, right? So they say angles A and B lie in the same quadrant. So what you need to look out for is for the start, right? You know that there's always four quadrants, right? So A, S, T, C, A, S, T, C. Then from here, right, you see sine is positive, whereas for the other one, tangent is negative. So which one is overlapping? So we understand that this will all happen in the second quadrant. Okay, so what we have here is that we're just going to draw it out. Okay, so when you draw it out, second quadrant will be somewhere like this here, right? So what we understand is this is your x and y axis. So their positive and negative will also play the same part. All right, meaning on this side here you are negative, on over here you are positive. So what are we looking at? This is angle A. So got to be careful. A lot of us like to label angle A here. No, A is actually outside. So this one over here is my basic angle. So we understand that for sine, right, is opposite over hypotenuse. So by doing your Pythagoras theorem, this is 3 square minus 2 square, right? So this one here will be square root 5. Then important thing to look out for, because we are on the left side of the x-axis, right? So got to make sure there's a negative sign from there. Okay, do the same for the other one. So draw in your second quadrant y-axis and x-axis. So y and x here. This entire thing is your B. All right. So tangent B, right? Tangent is always what? Opposite over adjacent. Just put in the number. Opposite over adjacent. Then now put in your negative sign because it's on the left side. Do your Pythagoras theorem. Square root 3, that's 3 square. So 1 square. This one here is 2. For your hypotenuse, it will always be positive 1. Okay. So what we're going to do now is we're going to answer cosine 2b. So cosine 2b means just look at the B triangle can already. So when we use this, right, we'll be looking at this one here. I will usually choose either the second or the third. It doesn't matter to me. So I'm just going to understand cosine square is cosine b whole thing square minus 1. So 2 cosine B, what's cosine B? Cosine B is adjacent over hypotenuse. Okay, so adjacent is negative square root 3 over 2, whole thing square minus 1. So you see, when you put your negative sign nicely in the diagram, then you are just taking whatever you see. You don't have to think, oh, is it positive? Oh, is it negative? No need. Okay, so square root 3 whole thing square, that will be 3 over 4. So 3 over 4, I'm just going to press my calculator. So this one here will give me 3 over 2 minus 1. So answer very nice. It's half. If it's ugly, then it will always be in terms of a cert. Okay, so this one we are done. Okay, then for the next one over here, oops, I think I had this here, then we removed it. Okay, so a lot of us are stuck at this one. Remember, we don't know secant because secant cannot see inside my diagram, but we know that secant is 1 over cosine. Why my line so long? Okay, so 1 over cosine from here. Okay, so cosine A minus B, that's under my addition formula, which means we're going to look at this one. Cosine A, cosine B plus sine A, sine B. Cosine A, cosine B plus sine A, sine B. Alright, every time also use the formula like that open one lah. Okay, so because we already draw, so don't need to like, oh, I don't want to draw there, like spend a lot of time. But when you draw, you see a lot easier to see. So now I want cosine A, right? So cosine A is this one ma. So adjacent over hypotenuse. So that is negative, wait send the line like so crooked. Negative root 5 over 3. Then cosine B, that is negative root 3 over 2, right? Then we do a plus. Sine A is 2 over 3. Then sine B is 1 over 2. Multiply from here. Okay, so 1 over. So you notice that the denominator is all 6. Yeah, beautiful. So from here, over 6. What is negative times negative? Positive, right? Root 5 times root 3, root 15. 2 times 1, 2. So you're just going to flip this around. So when you flip this around, I put here, this will be 6 over root 15 plus 2. Remember, you need to rationalize. So root 15 minus 2 over root 15 minus 2. Below, right, will surely give you a nice number one. So you can just press root 15. Oops, what happened? Plus 2 root 15 minus 2, like that. So this one denominator will just be 11. So that no need so mafan one. Then this one is 6 root 15 minus 6 times 2 is 12. So this will be my answer here. Some of yours, right, the answer is 12 minus 6 root 15. Then your denominator is negative 11. Okay, so this is a full question. Not very uncommon, so please take note of this one. It comes up quite often in exam, okay? Okay, this is the question that scared most of us. So let's take a look at this one here. So we have fx, we have gx. Actually, what is this fx and gx? This technically is like a y equals to something law. Also, it's something like, but why they use as fx? Because they want to show one graph and show the other graph. But actually, it's just y equals to, like a graph and then y equals to another graph from here. Okay, so they want the least and the greatest value of fx. Guys, you don't just put the numbers down. The examiner must mark. So you must put down the greatest, you must put down the least. Okay? So from here, you should put like that. Greatest value of fx equals to what? Then the least, okay, value is the bare minimum I must see. If you want to put the whole thing right, you got to write the whole thing out like that. Okay? Values of fx. So let's look at the pink one that I underlined first. The amplitude is 3, means my greatest is 3, my least is negative 3. Then there's a minus 1 and minus 1, right? So greatest is 2, and then my least is negative 4. All right, straightforward. Then how do we state the period? Remember period, this one never states, so degree or radian also can. So period, right, is always 2 pi over b or 360 over b. What is b? B is this thing here. Okay, so in this case, right, my period, okay, is you can write as either pi or 180 because they never say anything. So either one of this one. So answer, 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 answer. Okay, now you need to sketch, right? So many of you didn't notice this one here. So please always check the range and the boundaries, all the values, the x and the y from here, okay? So what we see here is that we have negative pi. This one is y, this one is x, right? Negative pi, this one here is pi, all right? If you are quite kiasu, right, you will put in the pi, negative pi over 2 and pi over 2. Personally, I would prefer that because that will show me where's my highest part of the graph and everything. So I'm going to draw this one first in purple, okay? So this one here is a fx. So I want you to understand this is technically y equals to, what is it? 3 cosine 2x minus 1, okay? So what is this here? Just now we understood the max, right, is 2. Then here is negative 4. Okay, so for most teachers, right, they would prefer to see these lines here. So that means at least you know where you are. Oopsie daisy, wait. Can see where you are going to touch. Okay, so you see, the period is pi, correct or not? So that means there's one cycle of my cosine graph. So cosine graph is always like that, like a mountain, right? No, this is basin, mountain is the other way around. So what we have from here is that you will know your middle points here, start here, lowest point is here, highest point is here. Okay, so what I have here is that I'm going to make sure I draw properly. So I'm going to curve, lowest point, curve, lowest point from here. So similarly for this side, lowest point is here, come back to here. So go down and then go down like that. All right. Okay, so just need to see like a W shape lah. All right. Then after that, right, this one, a lot of us, we were stuck at this one because we didn't know what is this. Like, what is this? This is what? Sine graph, cosine graph. No, this is actually a straight line, right? Because it looks like a y equals to mx plus c kind of thing, right? So what I have here is, this is y equals to 2x over pi minus 2. So the y-intercept is like like minus 2, you know what I mean, right? So let's say we see this, right? You just use the boundaries given, right? So straight line, we just plot points. So we put as negative pi, 0, and pi. Usually we use values like 0, 1, 2 when we're doing E-math, right? But then because this one here, right, you're going to cancel off the pi, ma. So let's say if you put inside the 0, right, then this one here will just be minus 2. Then this one here, okay, if I put in pi, cancel, cancel, 2 minus 2 is 0. Then if let's say you have, it is negative pi, huh? Wait, yeah. Wait, negative pi. If I put in negative pi, cancel, cancel. Oh, this one should be negative 4, my bad. So this one is minus 4. Then this one here is 0. Okay, then I can plot already. So at negative pi, he is here. At 0, he is negative 2, which is here. Then the last one is pi and 0. Oh, here. Okay, so then I will just draw my line. Okay, not very nice. Oh, very nice eh. Okay, so like that. So then I'll draw it. So then I'll label lah. This one is my fx graph. This one is my gx graph. But remember, they are just y equals to something. Okay? So this is how you do that part here. Okay, last one, killer for the last one for most of us. The number of solutions for this random thing here. Don't know what is this, right? But what you must know is that it has to be something that you already plot, ma. Okay, so it has to be something that you already plot. So you see, you will always aim to make the left side, right, look like one of the equations so that you can make it y equals to something. So you see, right, technically, if I compare this one here, this one, and this one here, y, right? So this one here looks the same. So I'm going to start from this one. 3 pi cosine 2x equals to 2x minus pi. Okay, what we can do first is we divide both sides by pi first, because we realize that if I want to make this one look like this, right, I don't have the pi ma. So if I divide both sides by pi, right, that's 3 cosine 2x equals to 2x minus pi. See, so nice. Then after almost the same way, you just need to minus 1 on both sides. Minus 1 on both sides. Wait, what am I doing? This one here, right, is a 2x over pi. Pi divided by pi is minus 1. So then we minus 1 like that. Can see? From here to here, I do stupid things just now. Okay, so then I'll simplify this. This is already the same, right? So this one is y now. This is 2x over pi minus 2. Then what do you notice? You will notice that, hey, this one and this one the same, eh? This one and this one the same. So by right, how to solve it is you got to draw this line and then see how many times they intersect. Lor. So just nice, that's the line that we drew just now already. So how many points of intersection? So that's why from here, we can see that there are 4 solutions and we're done. Okay, this one put a star. Review this one. This one usually graph, right? If it comes out like that, right? That's the one that threw most students off one lah. It's just like that, okay? Okay, I thought this one, the proving was quite okay. So remember, we try to meet in the middle if we have to. So we start from the left side first, because we always try to start from the messier one. See so many brackets, right? Rainbow, open it, open everything, okay? So this is, wait, what happened? This is sine A minus sine square A cosine A. This one here is cosine A, rainbow. This one here will be sine A cosine square A. The whole thing over sine cube. Okay, usually at this point you see whether there's something that can remove by itself, but you realize got nothing, right? So what I'm going to do is I'm just going to take my pencil. So when I take my pencil from here, right, I'm just going to try the right side. Okay, but cannot show people one. So the right side will be 1 plus, what's cotangent? Cotangent is 1 over tangent. So that means it's cosine cube A over sine cube A. So if I make them have the same denominator, right, it will look something like that. Okay, then until here, right, I'm a bit stuck already. But this gives me a good hint. You know why? Look at this. That means I'm aiming for getting sine cube, aiming for getting cosine cube. Lor. So how to get sine cube or cosine cube? This one I can change to 1 minus cosine square. This will give me cosine cube, right? This one can change to 1 minus sine square. That will give me sine cube, right? So let's try, okay? So this one here will be 1 minus cosine square cosine, cosine. This is sine A. This is 1 minus sine square, right? So you can guide yourself to what you need one. All right, so then this is sine cube A from here. Ayo, I give you all so little space, I feel a bit bad. Okay, okay, then from here, open up, okay? So when I open up, got to rainbow this guy. So rainbow, rainbow, rainbow. Wow, this one got a minus here, so scary. So minus cosine A plus cosine cube A. Okay, this is cosine A. This one here minus sine A plus sine cube A. Whole thing divided by sine cube A. I just write over first, okay? Okay, you notice something? See? Bye-bye. See? Bye-bye. So what are you left with? You're left with sine cube A plus cosine cube A over sine cube A. Should be a little bit familiar already because it's here. Ta-da, it's here. So since it's here, you just copy this over. Must copy, cannot just leave it like that one. Then must finish writing it. 1 plus uh cotangent cube A then equals to right hand side. Must show everything. Okay? Don't just stop and say, okay, done. Show like that. No, you must straight away write until all the way to the end. Alright? So not scary. So things to take note from this question is you have to do two things. Number one, if you need to expand, just open up everything. Okay? Open up everything. Then after that, the next thing to look out for, if you start cheating from the other side, right, it will guide you to know what you want to look out for. So ours was we knew we needed the cube, 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 so we had to try to change slowly, slowly from there. Okay, so this kind of hands solve, love it because even touch wood you cannot prove, right? You can still solve it from there, right? So what I have here is that then for the next one, they said hands, right? So it should look something the same. Okay, so what I have here is that let me rewrite this thing here so that it looks more like the left side, okay? So this is sine A plus cosine A, 1 minus sine A cosine A. If I bring over this one here, this one becomes sine cube A here. This is 2 over 1. Correct or not? So now, right, this one looks exactly like this already. So since it looks exactly like this now, we got 1 over cotangent cube A equals to 2. Oh, okay. So then cotangent cube A, what I write cosine? Cotangent cube A is equals to 1, which means 1 over tangent cube A is equals to 1. So what's tangent cube A? Tangent cube A will be 1. And then a lot of times, right, of over here, right, what will happen is that I will start doing, oh, I want to change sine over cosine. But calculator can press tangent there. So you can straight away tangent A equals to 1 already. So you can do this already. So then they say 0 to 180. So it's in degree mode. So we're going to start with our main steps again, okay? So we have our basic angle. So basic angle will be tangent inverse, 1, which gives me 45. Okay, so then if I want to find A, first quadrant 45, positive, right? So positive tangent is first and third. So this is 225. But we only want until 180, right? So reject. This is the only answer. Don't do sine over cosine. Don't make your life difficult. Okay? Okay, last one. I hope the last one you all could tell that it's a what you call it, R formula kind of question because you can see they never ask you to do R formula, but whenever you need to solve and there's a diagram, there's no way to solve like sine plus cosine, right? You will just convert it to R formula from here. Okay, but most of you were able to prove. I'm quite impressed. Okay, because you all remember that we're going to cut with right angle triangle, right? So we look at this one here. Theta varies. Everything is in degree. Theta is in what you call this? Degree mode. Okay, so they want us to find OT. So OT will be this one here plus this one here for sure. Got to find them separately. All right. So there's a rectangle. So this is 90. So 180 minus 90 minus theta, right? What you get here is that this one over here is actually 90 minus theta. So if this one is 90 minus theta, then we sure know that this one here is theta. So find your theta first and do. Okay, I'm going to write upstairs because it's easier. Okay, I'm going to find OQ first. According to OQ, this is adjacent, this is hypotenuse. So cosine theta will be OQ over 1.6. So my OQ is 1.6 cosine theta. All right. Then for the other side, I need to find QT. QT, this is opposite. So QT over 0.5. 0.5 is from here, okay? Here, same. So then from here, QT will just be 0.5 sine theta. So easy, yay. So OT is 1.6 cosine theta plus 0.5 sine theta from here. Okay, sure. So now you need to solve. A lot of us got stuck because how are you supposed to solve? You don't know how to solve something like that, right? You can't straight away equate it to 1.2 because there's no way you can solve this. You can't make it tangent. You can't solve sine and cosine separately. So what you need to do is you got to make use of your R formula. So let's find out what's R first. So R is 1.6 square plus 0.5 square. So this one just square root 1.6 square plus 0.5 square. Okay, so this one here gives me 1.6730. Ugly answer, so be it. We're just going to let it be. You know why? Because you know the final answer, what? They never ask me to show as R formula, what? Correct? So I need to find alpha, tangent inverse, B over A. Press calculator in degree mode. And this is 17.3540. Okay, so now we're going to write out the R formula here. So for this one here, I'm going to do it in red so it catches your attention. R, okay, which trigo are you going to use? Use the first one. So cosine. What did I teach you about cosine? The sign will always be opposite. So 17.3540. Okay, so now you have rewritten OT. We can solve it now. So when we try to solve it, okay, slowly bring over. All right, so first, bring this over, becomes a divide. Okay, second is, why are you still here? Okay, bring over already, Second thing is, help me to bring over the cosine. So you get cosine inverse -1. All right, so what I need you all to do is for cosine, just be extra careful because the cosine was positive. We have our acute. Don't forget to come to this side negative just for a good practice, okay? So theta minus 17.3540, right? Okay, let's cosine inverse this guy. Okay, so this is 44.286. We're just going to go the other one, negative 44.286. Okay, so what we have here is that plus 17.3540, one decimal place, 61.6. The other one, negative 44 plus plus 17.3540. Oops, negative answer. Okay, we reject. But just have a good habit. Make sure you try to find both answers just in case for cosine. Alright, I reminded you all for cosine especially lah. Alright, okay, that's the 4 homework questions. Alright.